Yes. Yeah, we learned we need to get an adequate amount of sleep. And what are some of the consequences of getting inadequate amounts of sleep?
Not being able to remember what we did last time as quickly as I'd like to.
Exactly. Not remembering what the hell we covered just 2 days ago. Exactly. What else did we learn?
You need to mix.
Go ahead.
You need to mix up your measurements to figure out kind of that measure of workload, because they don't all usually come up with consistent findings.
Yeah, you need to mix up your measurements of workload, right? Because there doesn't always seem to be convergence across measures. It makes sense to add multiple measures. And what are some of the measures we talked about that you can use for workload assessment?
I mean, there's always self-report.
Yeah, so there's self-report, exactly. But self-report is inherently flawed. I mean, as we even saw with the polls, right, for this current election, self-reporting has a whole litany of issues associated with it. So what are some of the other things we can do beyond self-report?
You can measure it physiologically, but there are problems with that though, because other things could be affecting that, or like the environmental stressors.
Yeah. So when you say physio, what do you mean? Give me an example.
Like heart rate.
Exactly. Yes. So we have heart rate, we get a blood pressure, we get a respiration rate, etc. Right? And there are obvious issues with that associated with one, the known effect of observing something relating to physiology like heart rate, blood pressure, respiration rate will actually increase that. What's one other way we can measure workload? We can measure with performance, right? Oh, that didn't work. And that performance could be on a primary task, it could be on a secondary task, etc. Right? And there are positives and negatives to each one of these approaches. So it's usually best to at least use a couple to try and establish convergence across measures and to help cover in where the deficits exist in one measure. Any questions about what we covered last time? Awesome. All right, here's your fun fact of the day. The Twitter bird has a name, and its name is Larry. And I think that's hilarious. I don't know if you guys know who Larry Bird is, but former, what was he, a forward for the Celtics? And we already watched that Office clip, so we're moving on. All right, so today is going to be focusing on kind of accidents, preventions of accidents, workers' comp, things like that. We talked a little bit about worker comp issues related to low back injuries, but obviously there are a lot of accidents that exist outside of that. And so in total, and this is actually a little bit of a dated number, so it's probably a little higher than this, but the total cost to the US for workplace accidents is about $800 billion a year. And that can include losses because of time, losses because of inventory, And then as you see in the next point, also includes losses associated with workplace death and injuries. And it wasn't until the early 20th century that kind of these safety procedures and safety mechanisms were put into place to kind of help guard against, yes, like your car accident, exactly, to guard against some of these unsafe practices. And it largely arose from the Triangle Shirtwaist factory fire. I don't know how to struggle. That's a tongue twister for me. In 1911, and I don't remember all the specifics. It's in your book, but I think it was a case where they had like 70 women and children die in a fire in that factory when there was only one door exit to get out of that environment. So obviously, this sensationalized in the news at the time and kind of allowed calls for greater regulation and greater protections of workers in factory environments. And as you'll see when we get beyond in 1911 and we start talking about modern workplaces, there's focus even beyond kind of that factory or assembly environment and even into modern workplaces. And so the establishment of the workers' compensation or workers' comp, as you'll hear it referred to, is to provide sure, prompt, and reasonable income and medical benefits to work accident victims or income benefits to their dependents, regardless of fault. So something happens at work, you get injured, you can't work for a while, workers' comp will allow you to still maintain some degree of income until you're able to get back on your feet. It also attempts to provide that single remedy to avoid the delays associated with going to court, the costs associated with going to court, workloads arising out of personal injury litigation. Right? It's an attempt to streamline that process and not have you mired in legal battles. Lord knows if you've ever gone through trying to get your insurance company to pay out if you have an auto accident, you know how long it can take, months, sometimes even years at the extreme. So this is an attempt to do away with that. Obviously, eliminating the payment of fees to lawyers and witnesses, encourage the maximum employer interest in safety and rehab through an experience rating mechanism, right? And so now the employers are getting feedback, and as you'll see with things like OSHA that we'll talk about in just a second, there can be actual penalties to employers that aren't providing safe work environments. And it also creates a recording mechanism by which we can establish the causes of accidents, frequency of accidents, etc. So following that pervasive feeling growing in the workplace safety was not considered, the federal government established the Occupational Safety and Health Act, or OSHA, which is the governing body that publishes the safety standards for an industry. In the 1970s, NIOSH was formed, the National Institute for Occupational Safety and Health, which is kind of the review body, which then prepares recommendations for those OSHA standards. So when we had that recommended weight limit for picking things up. That's also referred to as the NIOSH lifting equation. Right? Came out of research from NIOSH. So when we're talking about accidents, we mean everything that can be caused by social norms, management defects, and then the obvious physical hazards. Right? A slippery floor can be an issue, as can the social norms of not wearing adequate safety gear. And if you have auto insurance, you know the next two bullet points to be true, especially for Guy. Younger people tend to have more accidents. That's why under 25, you have to pay more for your auto insurance. And this is not just auto related. This is across the domain. And then guys tend to get into accidents at 3 times the rate of women. So what are some of the predicting factors for getting into accidents? One would be job experience. So 70% of accidents, all accidents, occur within an employee's first 3 years on a job. Right, so inexperience can contribute to, for example, loss of situational awareness, which can have a cascading effect. Also things like stress, fatigue, drugs, and alcohol. Right, we already talked last time about the negative consequences of sleep deprivation. Thinking of all the effects, all the manifestation of those effects in a workplace. Job characteristics inherent to the job you're performing, which includes physical and mental workload, stress-inducing factors like constant observation, etc. We'll talk about leadership in a lecture or two. Obviously, controls and displays, right? We've talked about this ad absurdum. All the ways bad controls and bad displays can lead to bad outcomes. Things like electrical hazards, mechanical hazards, etc. Also have issues from pressure and toxic substance hazards, right? So when you think to any sort of interaction with radioactive material, that presents a real potential threat to not only the worker, but if the worker or there are not adequate safety procedures to the surrounding community. Back when I was in Colorado, I went on a brewery tour and they were talking about the pressure buildup in the tanks where they're actually fermenting the beer. And they were telling me of a sister brewery they had that had just had an accident where the pressure built up so much that it actually exploded the tank, the fermentation tank at the brewery, and sent shrapnel across the brewery. We also have things like asphyxiants, right? Things that slowly essentially suffocate you, irritants, poisons, and carcinogens. And these can be kind of instantaneous hazards, or they can be hazards over the long period or a long time of exposure. Issues within the physical environment, so bad lighting, noise and vibration, right? So when we talked about the ear, we talked about how excessive noise can damage the ear, but as can, not that loud of noise for longer periods of time. Repeated vibration can have substantial negative consequences on your nervous system. Right? You may have experienced even kind of the least extreme version of this, where if you're mowing the lawn for an hour and you finish, you feel like your hand's tingling or you've lost sensation in your hand. Long-term exposure to that vibration can leave lasting damage. And then things like temperature and humidity, right? We've talked about already the consequences of it being too hot or potentially too cold, right? You can have cold-related injuries. Humidity aggravates that, which makes me think working outside in Alabama from like May to September should be illegal. It seems cruel and unusual. And then you have things in the physical environment, right? So what are the fire hazards? What are potential radiation hazards? Falling from only 11 feet has about a 50% mortality rate, falling onto hard surfaces. And then exits and emergency evacuations. What are the best ways in which to design a space to allow everybody access to the exits? Is there adequate illumination in the case of a fire, et cetera? You also, and we'll talk about the kind of human aspect a little bit more later today, but you also have to design knowing humans' propensities in emergency situations, right? You can actually go on Wikipedia, and there's a list of all human stampedes in recorded history, right? This isn't just things like Black Friday. This is like you had over in Germany a few years ago at the music festival, where people started panicking about their ability to get out of that music festival. They wound up stampeding over each other. And so you can think about the lead up to an accident as not being kind of a univariate analysis, right? So first we have to have exposure to some hazardous situation, right? Something has to be atypical or undesirable. And first, we have to be able to perceive that hazard. Right? So this includes the individual, right? The state of your alertness, how engaged you are in the task. If you don't perceive that hazard, that's going to lead to an unsafe behavior. If you do perceive that hazard, you have to make sense of that hazard, right? So this is just that human information processing model that we've talked about before, or those stages of automation, where you have to perceive or collect that information, you have to make sense of that information, you have to make the decision to avoid whatever those consequences would be, and then you have to have the physical ability to carry out that action. Right? And so you can see at every stage here, there is a host of things we need to consider, including things like experience and training. And this is where you can start getting in automated aids, right, to help with that process of threat detection. So now, if we're able to design some sort of alert system, we can help eliminate the likelihood that you're going to have a failure at really any of these early stages. Questions so far? Awesome. All right, so when we talk about human error, we can talk about two different types of error. Errors of omission and errors of commission. So errors of omission is the human not doing something they should have. Example of error of omission would be not turning on your turn blinker when you change lanes. Error of commission is doing something you shouldn't do. All right, so instead of hitting the brake, you accidentally hit the gas pedal. And these errors can either be unintended or intended. So when it's unintended, we can label it either as a slip, which is when we didn't intend to do that action. You slipped in your pressing of that gas pedal. Or it can be a lapse, right? We didn't intend not to turn on our turn signal. It just happened. And when we say intended errors, we don't mean some sort of malevolent decision to screw up, right? There can be a host of things where you carried out the action you intended to carry out. It just wasn't the right action, right? So we can split that into knowledge-based mistake, right? So you fail to adequately perceive or understand your environment. It could be a rule-based mistake. So you adequately perceived the environment and what was going on, but you made the wrong decision based off of that. Right? If we think of these in terms of if-then statements, you just executed that wrong if-then rule. And then you have violation, which is that malevolent doing the wrong thing. You just wanted to see if you could jump that bobcat over the lake. And so we have a propensity to try and blame the person who was involved in the accident. But it's important to think about the combination or the confluence of factors which lead to that accident. All right? The poor environmental conditions or poor human factors, poor sleep schedules or the fatigue, poor training, poor job support, poor maintenance, attitudes of management, workplace climate, etc. we'll talk more about this when we talk about leadership shortly, but I would strongly recommend everybody read this book, Extreme Ownership. And it's really hammering on each one of these as a whole, right? In that it's from, at least he writes it from a management perspective, but from a management perspective, it's never the worker's fault, right? It's to some degree your fault for not providing adequate training or not foreseeing what are the environmental conditions which could have led to this. Right, and so when we think about that passenger who rode in that French jet and accidentally ejected themselves, you can say, well, it was a stupid human error. Right? But it's your job as a human factors psychologist or human factors engineer to anticipate all the ways somebody could screw that up and prevent those from happening. Right? That could have been just a training issue, right? Maybe from a control perspective, that ejection handle was exactly designed as it should be, but there should have been some anticipation about the training necessary for those in the ride along. Or perhaps you just redesign that ejection handle to prevent something like that from happening again. Right? And it fits into this kind of Swiss cheese model when we think about accidents. Right? We're going to have a litany of hazards in any workplace environment, but each one of these things, we can call this the environment. This could be training. This could be management. Right? The idea is you need to close that hole somewhere, right? And so accident prevention is all about this, trying to establish where are those holes and what are the redundancies we can establish to prevent accidents like that from happening. So when we're designing equipment, when we're designing systems, we need to do the best job we can in trying to identify what are those potential hazards. Could we have seen that somebody would accidentally grab that ejection seat handle? In so doing, we create what we call the preliminary hazard analysis, which is an attempt to evaluate the combinations of task actions, potential users, use environments, to develop the list of most obvious hazards. All right, if you think back to old model cars, they had that cigarette lighter where you pushed it in and you would take it out and it would be nice and hot. Your ability to manage that while sitting in traffic would look probably a lot different than if you were trying to engage that and use it while traveling down the highway. So it's not enough to just say, okay, in this sterile environment, how safe is this action we're performing? We need to think about it out in the real world. You also need to think about the fact that people are going to misuse what you're delivering to them. So does anybody do any woodworking and know what's wrong with this problem or what's wrong with this picture?
He's moving towards the saw.
Yeah,
with his hands.
So a couple things. His hand is right in the path of the blade, which you never do. He also, you can see over here, this guardrail should be guiding that piece of wood, because one of the things that can happen with table saws is if this wood gets rotated ever so slightly around the back of this blade as this blade is spinning up, it causes what we call a kickback. and it'll kick the wood literally back at the person, which is an issue for a bunch of reasons. One, it could actually remove your finger. Seen that happen before. Two, if you're pushing forward and the board slips out from under your hand now goes into that blade, right? And so whether it's deliberate misuse or accidental misuse, people are going to find creative ways to misuse it, right? You can find videos online of, so when we talked about Tesla has that attention check wherein you have to jiggle the steering wheel every so often to make sure that you're paying attention and not asleep in the car. But people have figured out that you can just put a weighty object in that steering wheel, wedge in orange in the steering wheel, and that gives the steering wheel enough of a haptic feedback, right? So people are deliberately figuring out how to bypass the safety procedures for that product. So you can perform a failure modes and effects criticality analysis, which isn't typically done on humans. It's typically done on the actual mechanics of a product. But we can apply it to the actual human and figure out what type of errors may occur at each stage. All right, so in this case, let's say we are putting together a lawnmower, and we want to know, as Husqvarna, what are the potential issues associated with having human assembly of this part? Well, one of the potential ways people can screw it up is over torque that bolt setting on the blade. You over torque it, that bolt can fail, at which point that blade comes off that mower, and you can have a litany of potential issues there. Right? And so you can think about through every step of the process, what are the ways somebody can screw this up? And if they do screw it up, how big of an issue is it that they screwed it up? It also helps to perform a fault tree analysis. Which involves us, hopefully, predicting, rather than doing kind of a post-mortem, an undesirable event like a fire. And think about, okay, what are the contributors to that fire? So let's say we're working for SpaceX right now, and we know that one of the biggest threats to the astronauts in that Dragon space capsule would be a fire. So let's try to identify all the potential places we need to establish redundancy and protection against that fire. Well, obviously, you can only have a fire if you have three things. You have to have a fuel, you have to have an oxidizer, and you have to have an ignition source. Well, there's really no way to get around the fuel and the oxidizer for SpaceX, right? That's just part of the desirable environment in which you have to launch. Right? But you can also think about in the actual Dragon space capsule, you're going to have some degree of fuel, just with paper, flammable materials. What are the things we can actually do to reduce the fuel? So making the spacesuits flame retardant. You're going to have an oxidizer, right? You have to pump in breathable air into that environment. But then what are the ignition sources in that space capsule? Well, an ignition source could be an open flame or a lighted match, a hot surface, or an electric spark. It's probably not the case that anybody sitting atop the Falcon 9 has an open flame or is lighting matches in there. Right? But they got a lot of computers in there. So potentially one of these systems overheats. Or you could have an electric spark, like what happened for the Apollo mission on the launch pad. Right? And so you can go through and create these kind of designs. And the important thing is a differentiation between and statements or statements. Right? An and statement, as represented up here, you can see depictions down here, the and or, indicates that you have to have each of those three to have that outcome, right? The or is you just need one. So you can go through and think about, okay, for any given accident, you need some sort of system vulnerability and an unsafe act. Right? That unsafe act could, at the perceptual stage, be understood or not known. Right? Maybe you didn't perceive that warning, or maybe you didn't read it. Maybe you didn't even understand that warning. And so you can see how you can start mapping through and establishing all the potential threats and risks in a certain situation for a given design or interaction with your technology. Questions at this point?
I have a question.
Yeah, what's up?
Yeah, I'm not sure if you had asked earlier, but on the back on the example you used with the fermenting tank that blew up, do you know or do you happen to remember what steps they took to make sure that didn't happen in the future?
Yeah, so the reason it blew up, it was a faulty valve on that pressure release. And so when you have these tanks, they are trying to regulate the amount of pressure on the inside. And so they've got a valve that they can open and close to regulate just how much pressure is in there versus actually being released. And for whatever reason, that valve didn't open, didn't relieve that pressure, and it continued to build up. And so the story I heard was in relationship to what this brewery I was visiting was doing to make sure that these valves are actually working. And so what they did is put the very end of that hose that was coming out on the the outflow side of that valve into a bucket of water, so they could constantly monitor whether or not that water was bubbling to see whether that valve was working. Because if not, if that valve wasn't letting off pressure or any of those gases associated with the fermentation process, they needed to essentially just open the entire tank to vent that off. Does that answer your question?
Yes, it does. Thank you.
Yeah. Yeah, so you can have solutions that are kind of low tech versus high tech. One of the things, so I read a book about Stuxnet, which was, again, this computer virus that was designed to disrupt Iran's nuclear program. And one of the things they did in the Stuxnet was, in addition to issuing commands to the centrifuges, was to essentially override any of the redundancy of, here's a warning, and also it was essentially just putting out fake data about the centrifuge, right? And so what they were attempting to do was remove that bucket from that fermentation tank to say, nothing to see here. Everything seems to be working fine until things really went south. And so as part of that accident prevention, you need to think about, okay, what are the potential consequences of a faulty warning system? And this is why so many high-risk environments have multiple redundancies. That's why your hot water tank has a blowout valve. And after a certain pressure is reached, it'll just blow out that valve and relieve all the pressure rather than exploding your entire tank. So once we've identified the hazards, how do we control and reduce those hazards? And once those control methods have been established, we need to consider what other hazards might arise now as a function of this new alternative. All right, so let's go back to the Tesla example, and this isn't how it played out, but let's just say it did. So let's say Tesla now saw that people were using those oranges to override those torque sensors on the steering wheel. And what they decided is, okay, we just now need to increase the amount of torque necessary such that an orange can't override that. Well, that may have defeated that, but what if they set that torque requirement so high that you had to yank the steering wheel, which would make you veer into other traffic? What effects of control are there on the subsequent usefulness of the product? Right? Is your engineered solution going to make that product either unusable, ineffective, etc.? And then once we engineer that solution, what's it going to do to the ultimate cost of the product? Is it going to now make that product so expensive that it no longer seems worth the price? For some industries, specifically high-risk industries, like the airline industry, all accidents have to be investigated. By law, they all have to be investigated. And anytime you see incident reports, what this is referring to is an incident would be something that could have resulted in injury or death, but didn't, right? It was a near miss. And data for incidents in industries, like the airline industries, are collected such that you can actually go and see the number of near misses for the aviation industry in the US. And those near misses can be things like close passes. And I think the FAA defines an incident as two planes flying within a mile of each other. But also things like go-arounds, right? So they had to throttle up because they were going to miss their landing, or close calls of one plane pulling out onto the runway when another was coming in to land, etc. And so even when we establish these safeguards, right, these engineered solutions, humans going to override them where possible. So every day, with all types of devices and technology, we have that choice between the safe and the unsafe behavior, which starts as a knowledge-based decision process, right? Think about driving. We start speeding because we make the calculation that, okay, there's not much of a risk to me in this situation because I'm on a flat road and there's nobody around me. But it can then become a rule-based behavior, or even automatic, such that you're no longer thinking about the violations towards safety, whether that be knowledge-based or rule-based. And obviously, as we talked about earlier in the semester, humans are very imperfect decision makers. We'll do things like satisficing. Can somebody remind me what satisficing is? Yeah.
Maybe it's when we do things to the extent that we find acceptable. Like
Yeah.
this is good enough.
Exactly. Good enough. Right? How many times have you heard somebody say, yeah, good enough? Right? In a lot of situations, that may not be a bad thing, but you can think about the litany of situations or environments where satisficing would put you in a really bad position. Obviously, heuristics, right? If we're thinking about the availability heuristics. Oh, come on. What are the consequences? You never hear about anybody dying from X, Y, or Z. You'll be fine. Biases inherent, things like the availability, or excuse me, not the availability, the anchoring, bias, etc. So severity of injury has a greater effect on likelihood of risk perception, right? And so even if nothing changes about how likely an outcome is, the more severe the injury associated with that, the more likely people are to think, well, okay, that's a real threat. Right? It's why people to this day remain a lot more concerned about flying than they are about driving, because they've been in automobile accidents without death or serious injury. But that availability heuristic plays that major role. People also tend to evaluate which option to choose by weighing the costs and benefits, right? So those costs could be financial or time, inconvenience, right? Anything that would be a psychosocial factor in our interactions in general can be seen as a cost. I'm going to run out to the supermarket. Does it really make sense for me to go blow out that candle over there? I'll be back shortly. All right, what are the costs associated with that? There's no real benefit in your mind. Then your dog knocks over the candle. And so warning signs, we're going to talk a little bit about the display of warning signs and best design principles for them. So there's no real consensus about the number and type of warning labels that should be placed on products, right? You can see a variety of warning labels that are presented on products, everything from like tobacco, so in cigarettes, we'll have the warning about this product can cause cancer. Of course, to the state of California, it seems like everything has been known to cause cancer. But you should also consider things like, what is that signal word conveying? The word danger conveys a much greater severity than does the word caution. If you see a sign that says caution, you're much less likely to continue reading than you are if you see a sign that says danger. You then want to include a description of what that hazard is, right? So don't just say danger and then not explain what that danger actually is. Danger, risk of falling. Danger, risk of electrocution. Caution, traffic merging ahead. Present those consequences. Right? The severity can be conveyed in such a way that makes people reevaluate their decision, right? Saying you could die versus you could be mildly inconvenienced is going to have a substantial impact on people's decisions. And that's why those campaigns that label tobacco products have been so successful, because they'll say you could die, you could get mouth or throat cancer, etc. And then provide some sort of description of the behavior needed to avoid that hazard, right? What should you do or what shouldn't you do? Watch for fallen obstacles, wear a hard hat, check your safety harness, etc. I also want to make the labels as noticeable as possible, right? So we've talked about things like salience and the actual display design. So make them salient with colors or placing them in that area that's going to minimize the effort, right? Close in on the area humans are normally foveating. And if you're using pictographs, you want to make them obvious and understandable. I genuinely have no clue what they're trying to convey with this real-world pictograph here. Maybe this is not a child drop-off spot, but that's all I can come up with. So again, like I said, that word choice can have a dramatic effect on people's perceptions of the severity. So danger usually conveys an immediate hazard. It's going to result in severe injury or death. Warning, hazards that could result in personal injury or death. And caution, hazards or unsafe practices could result in a minor personal injury or property damage. However, with these things, you want to avoid that cry wolf effect. Right? If you're saying danger in every situation, when it's not really that big of an issue, people are more likely to tune out those warnings, which could have devastating consequences. All right, so let's do a little quick class critical thinking activity here. What warning signs do you regularly encounter that made no sense the first time you came across them? And how would you redesign them to make more sense?
Okay, so this is a little off topic, but it reminds me. So I studied chemical engineering in undergrad and worked in a chemical plant right out of college. And there were so many warnings that would come up on the control panel for the operators because they're monitoring this massive chemical plant. And they would get several, and if they didn't know what they meant or if they were confusing, they would just ignore them.
Oh, good.
And so it reminds me, yeah, and it was an older plant, so there were like pieces of instrumentation throughout that didn't work and hadn't worked in years. And so they were pretty used to just ignoring like lights that were flashing because maybe they were never turned off when the instrumentation stopped working or whatever. So I think it's just an example of how if you don't clearly label or make it obvious what you're warning against, someone's just going to ignore it or obviously not be warned.
Yeah, absolutely. That's a great example. Yeah, and you would hope that in any sort of chemical engineering plant, there would be a strict adherence to over-reliance on caution. But I totally get the human inclination to kind of just ignore them if given the opportunity.
Yeah, I mean, the company I worked for actually was the leader in occupational safety in that industry. So they actually were doing better than a lot of the competitors, but it still goes to show that if you're not making it clear what people need to be concerned about, they may not know to be concerned.
Oh yeah, absolutely. Yeah, so one example I have, when I was in Costa Rica years ago, there were poisonous trees, and I don't think they would kill you, but I think they would severely irritate your skin. And they had this grove of poisonous tree, and they had low-hanging branches, and they were beautiful. And they had one sign kind of out of the way saying, warning, these trees are poisonous, don't climb on them or touch them. And as I came across that sign, I saw an entire family taking a family photo with all of them hanging off of the tree. And so while it wasn't necessarily that the sign didn't make sense, it was an issue of placement of that sign, right? You could easily access these trees without ever coming across that sign. Anybody else have any other examples? All right, so we only have 2 more lectures for this class, and then we have a guest lecture, and then we'll do a series of presentations at the end of the semester. Next time, we're going to talk about job design, selection, and training. This will be kind of a precursor or preview to Marlon, who's going to talk to us on, I think, the 17th about doing essentially this for Facebook. But before we end class today, what were some of the main takeaways from today's lecture?
One takeaway is that high risk job environments require investigations after each and every accident, no matter the magnitude of the accident.
Yeah, absolutely. Oops. Awesome. What else?
I thought it was interesting about, of course, there's individual differences, and then with that, age usually can be a big indicator of possibly having an accident, but it's really hard to actually identify those accident-prone individuals.
Yeah, so you do have things like age and sex contributing to that, but you also have things like time on job. What in the world? Yeah, and making sure that you're able to identify, even across that, what are the occupational specific hazards associated with performing that job. Somebody give me one more thing. Yeah, Andrew.
There are multiple levels while you're doing an action where something could go wrong. And what we should be doing is making signs and other warnings that add redundancy to that. So
yeah, exactly. Yeah. So making sure that at every step in the process of interaction with the system, you are establishing what are the potential ways in which this could go wrong, right? Thinking overly neurotic about, what are the ways everything here could potentially, turn disastrous. Avery says the attitudes and attention of employees is equally as important as the employers in preventing injury. Without one of those, without one, the other is unlikely to be as cautious. If the employer isn't worried and doesn't take the right measures, the employees might be unaware. Absolutely, yes. So creating this kind of culture of safety wherein you're not permitting people to get away with not wearing their safety equipment or doing the proper safety checks, right? So having that entire environment which promotes safe actions and overall attention to detail, et cetera, things like that is great. Perfect. All right. Well, have a good weekend, and I will see you all on Tuesday.
Hey, Nate.
Yes.
Dr. Vager had mentioned that she wanted to